All right, Chapter 3, Section 4, Arithmetic Sequences. Let's go. All right, so a sequence is a set of numbers with a common difference or division. So a common difference or division between them. So as you go from one to the next, there should be a common number that is between them. That makes a sequence. Terms would be the numbers in the sequence. So the first term, the second term, the third term would be the first number, the second number, the third number in the sequence. All right, so an arithmetic sequence, so we put those together, is a numerical pattern that increases or decreases at a constant rate or value that is called the common difference. So when you write an arithmetic statement, each term in the arithmetic sequence after the first term can be found by adding the common difference to the preceding term. An arithmetic sequence could be, A would be the first term, A1 plus the difference, A2 plus the, and that would equal A2. A2 plus the difference equals A3, A3 plus the difference, and so on. So D is the common difference, and A1 is the first term, A2 is the second, and so on and so forth. All right, then there's actually an nth term. So once you figure out what the formula is, the nth term would be whatever number we wanted. So if we wanted to say they get the 13th term in something, we could just insert it in there. So the nth term of the arithmetic sequence is the first term, A1, and the common difference. So A to whatever number is A1 plus n minus the number for n minus 1. So that would be like if we wanted the 10th, it would be n minus 9 because we're adding the first one. That's why we have to take one out. And then times whatever the difference is. And n has to be a positive integer. If it's negative, it's not going to work. All right, so is this, and I determine whether this is an arithmetic sequence or not and explain. So we're looking for a common difference. So when we write them all out here, we can see there's plus 2, plus 2, plus 2. So, therefore, I would say that yes, this is an arithmetic sequence because there is a constant difference. Number 2, is this a arithmetic sequence or not? So we're going to write them out and see if we can find something constant in between them. So minus 1/4, minus 1/2, minus 3/4. I'm going to say no. This is not an arithmetic sequence because it is not a constant. Now, it is a pattern, but it is not an arithmetic sequence. All right, pause this one, give it a shot. All right, is there a constant between these? So, looks like this is plus 2, this is plus 4, that is plus 2, that is plus 2. 2, 4, 8, 10, 12. That's not constant because this 4 here is not the same. So this is not an arithmetic sequence because it is not there's no constant between them. All right, let's try this one out. All right, so, and go. All right, so 2/3, 1, 4/3, 5/3. If we rewrote this just a little bit, if this was 3/3 and this was 6/3, now this would be 1/3 plus 1/3. Sorry, that was a terrible 3. Plus 1/3. I'd say yes, this is an arithmetic sequence because there is, man, I cannot write a 3. There is a constant of 1/3. Right, an arithmetic sequence, so they're telling you it is -8, -11, -14, -17 represents the daily low temperature in Fahrenheit. Find the next 3 terms. Okay, so we find the common difference by subtracting them to the successive terms. So we figured out that's -3, -3, -3. So we need a -3 more out. So the common difference is -3. We subtract 3 from the last term in the sequence to get the next term and continue until we find the next 3 terms. So 17 minus 3 is -20, -20 minus 3 is -23, -23 minus 3 is -26. So my next 3 terms are going to be -20, -23, -26. All right, pause this one, give it a shot. All right, so looks like we're going to have plus 5, plus 5, plus 5. Hey, so 73 plus 5 is 78. 78 plus 5 is 83. 83 plus 5 is 88. So it looks like A would be my answer. Keeping going. All right, the arithmetic sequence of this represents the total number of dollars she has earned in her account after her weekly allowance is added. Write an equation for the nth term in this sequence. All right, in this sequence, we can see that A1 is 1, because they told us it's right here. Find the common difference would be the next step. So we find that it's adding 9 to each one. Yeah, I skipped a little bit there. Stick with me. Adding 9 to each one. So the common difference is 9. So we're going to use the formula that we learned a little bit ago, and you'll probably have to go to your notes to do this. So the nth term in the sequence. So here is that term. So A1 will be the first term. So A1 will be replaced here. And we found the difference was plus 9, so we put a 9 here. So we don't have to add the add symbol, but if it was negative, we'd have to use negative there. So plus 9, or times 9, sorry, because it's going to be a multiplication there. So I distribute that property out, combine like terms, which would be simplifying. So there would be, so we're going to check, make sure that comes out to the same right numbers. There's my first 3. And those match up with the original 3 numbers that we had. So I can say that my answer would be a to the nth equals 9n minus 8. All right, so I'll find the 12th term in this sequence. So we're going to replace n with 12 and in the equation that we just did. So here's our equation that we learned a little bit ago. We're going to replace n with 12, multiply that out, and simplify it. So multiply, then subtract. There's the number you get. A equals 100. So a to the 12th would be 100 by the terms that we did there. Now we're going to graph the first 5. Well, we're going to give that all to you here. So graphing, we'll find 1 to 1, 2 goes to this, 3 goes to this. So n, and then a to the n. Define our numbers here. So our answers are going to be, so we put the n's on the bottom and the a to the nth, whatever it comes out to. They fall in a straight line. That means that the arithmetic sequence is linear, which means it's a line. All right, pause this one, give it a shot. All right, the arithmetic sequence 2, 7, 12, 14, 17, 22 represents the total number of pencils she has collected after she goes to her school store each week. Apparently she doesn't lose them like most students do. Write an equation for the nth term in the sequence. So our equation was a to the nth equals, I believe it was a1, and then n minus 1 times the difference. So our difference, this looks like plus 5, plus 5, plus 5, plus 5. Okay, they didn't change, so D is, that's horrible, is 5, and A1 is 2. So let's put that in there, 2, and then n minus 1 times D is 5. We're going to distribute. Whoops. Distribute, so that would be 5n minus 5, 2 plus, hopefully I did this right, n minus 3 plus 5n. And we swap those, would give us D. Hey, I like it when it works. All right, find the 12th term in that sequence. So my 5n minus 3, go. Okay, 5n minus 3 equals a to the n. So if we meant the 12th, we're going to go a to the 12th equals 5 times 12 minus 3. 5 times 12 is 60 minus 3. That'd be 57 equals a to the 12th. And there we go. All right, does this graph show the first 5 terms in the sequence? All right, so we have A1 would be 2, A2 would be 5, 7. Yeah, this ain't gonna work because it's supposed to go up, not down. So no, that is not the graph, it's backwards. And that's all she wrote. See you in class.